Imagine this. You're standing on Earth, looking up at Mars. A small, glowing red in the sky. It feels close, reachable, like if we just built a powerful enough rocket, we could point straight at it and go. But that's not how space works. In fact, if you tried to fly straight to Mars, you would miss it completely. Not because your rocket isn't fast enough, but because you fundamentally misunderstood how motion in space works. To understand why, we need to zoom out. Way out. Earth is not sitting still. Right now, as you're watching this, you are moving around the sun at about 30 kilometers per second. That's over 100,000 kilometers per hour. And Mars? Mars is also orbiting the sun at about 24 kilometers per second. So when we launch a spacecraft from Earth, we're not starting from rest. We're already moving extremely fast sideways. And that sideways motion never goes away. This is the first major idea. In space, you don't just go where you point. You go where your velocity takes you. So if you try to aim directly at Mars, your path doesn't look like a straight line. It bends.
Why?
Because gravity is always pulling you toward the sun. So instead of flying straight, your spacecraft enters orbit around the sun, just like Earth and Mars already are. And once you understand that, everything changes. To travel from Earth to Mars, we don't aim at Mars itself. We change our orbit. Specifically, we use something called a Hohmann transfer orbit. This is the most energy-efficient path between two circular orbits. It's not straight. It's an ellipse. One end touches Earth's orbit, the other reaches out to Mars. When a spacecraft leaves Earth, it performs a burn called transmars injection. This doesn't aim the spacecraft at Mars. Instead, it slightly increases its speed by about 3 to 4 kilometers per second. That small change is enough to stretch its orbit from Earth's path out toward Mars. And from that point on, the spacecraft is basically falling around the sun on a carefully calculated path. But here's where it gets even more interesting. We're not aiming for where Mars is. We're aiming for where Mars will be. Because while we're traveling for months, Mars is still moving along its orbit. So, if we launched when Mars was directly in front of us, we'd arrive late. Mars would already be gone. This is why timing is everything. There's only a small window, about every 26 months, when Earth and Mars line up in just the right way to make this transfer possible. If we launch too early or too late, we either miss Mars entirely or need huge amounts of extra energy to correct the trajectory. This is also why missions sometimes wait. For example, Escapade launched before the ideal alignment, so instead of heading straight to Mars, it entered a temporary orbit and waited for the right moment to continue. Because in orbital mechanics, patience is often more important than power. Let's talk about distance. At its closest, Mars is about 55 million kilometers away. At its farthest, it's over 400 million kilometers away. And even using the most efficient path, it still takes about 6 to 9 months to get there. You're not just traveling across distance. You're sinking motion across millions of kilometers with a moving target. And this is the part most people don't realize. Space travel isn't about engines or thrust. It's about geometry. It's about timing. It's about understanding how objects move under the influence of gravity. When we send spacecraft to Mars, we're not forcing our way across space. We're working with it. We leave Earth's orbit, enter a new path around the sun, and let physics guide us to exactly where Mars will be. So no, we can't fly straight to Mars. Because in space, there is no such thing as a straight line. Only orbits and the precision to move between them. Thank you for watching. If you enjoyed this video, please leave a like, subscribe, and comment down below what you'd like to see next.